Hi everyone, in this video I'm going to go through section 5 of your lab handout, which is testing the AM Superheterodyne receiver that you've built with large carrier amplitude modulated CSV input. Now for this part of the lab, we're not going to be using the Waveforms app at all. Instead, we're going to be using our own custom application called the EECS AM Superheterodyne app, which will allow you to load the CSV data corresponding to the 4 amplitude modulated audio stations, change the local oscillator frequency, and then stream that CSV data to the 82 with multiplication by the local oscillator. Now keep in mind that although you haven't actually built a local oscillator as part of your Superheterodyne receiver, that this application, EECS AM Superheterodyne app, will automatically use the local oscillator that's inside the 82. And the application's user interface will allow you to turn a knob which corresponds to changing the local oscillator frequency. So close out of the Waveforms app. Now to make the installation a little simpler, we've created an executable installer that will install the EECS AM Superheterodyne app on your computer. So double click on the setup.exe file from Canvas. The installation wizard will bring you to a screen that asks you to accept the license agreement of the software. The next page will ask you to enter the username and the organization. For the username, enter your name, and for the organization, enter UMISH. The next page will ask you to choose the destination folder of the app installation. You can leave that the default. Choose the complete setup type, and then click Install to begin the installation of the app. Once the installation finishes, you should see a screen that says Install Shield Wizard completed, and then click Finish to exit the wizard. Notice that the installer automatically created a shortcut on the desktop corresponding to the EECS AM Superheterodyne app. So double click on the EECS AM Superheterodyne app. Now before opening the EECS AM Superheterodyne app, make sure that your 82 is connected to your computer, since right when the app opens, it will try to connect with the 82, and if it can't find an 82 device connected, then it will throw an error and you won't be able to use the app. The first step is to read the data stored in the CSV file. So to do that, click the Select CSV File button, navigate to the folder storing the mystery 180.260.340.420.csv file, click it, and then select Open. Once you've opened the CSV file, then click Load CSV Data to actually load the CSV audio data into Python. Now this will bring up a warning message saying, are you sure you would like to load the LC-AM modulated CSV audio data into Python? This may take a couple of minutes, since if you click Show Details, you can see that the file size is almost 1 gigabyte, which means depending on the speed of your computer, this could take quite a bit of time. In any case, click OK, and then once it finishes, you should see a message logged to the console that says Completed Loading CSV Data. Now just as a reminder, this CSV file, mystery 180.260.340.420, contains 4 amplitude modulated audio signals, one with carrier frequency 180 kHz, the second with carrier frequency 260 kHz, the third at carrier frequency 340 kHz, and then the fourth at carrier frequency 420 kHz. This represents 4 AM radio stations being picked up by a Superheterodyne receiver, and then you're going to use the local oscillator to select different stations and then hear the output on the audio speaker. In section 5.2.1 of the lab handout, you're going to use the measured IF center frequency to calculate the local oscillator frequencies corresponding to each of the 4 different carrier frequencies. So each carrier frequency can be listened to by using 2 different local oscillator frequencies, and your job will be to calculate the local oscillator frequencies that will allow you to hear each of the 4 different audio stations. Now, in order to hear the output of a superheterodyne receiver, there's 2 ways you can hear the output. Either by using the audio speaker that comes with the kit, connecting one terminal to the output terminal of the DC blocking capacitor and the other terminal to the ground rail, or by using an audio connector as we did in Lab 3. I would recommend using the audio speaker that comes with the kit, unless that audio speaker is broken, in which case you should use the audio connector and then connect it to a pair of headphones so that you can hear the output of the superheterodyne receiver in your headphones. In any case, once you have an audio speaker or a pair of headphones connected to the output of the superheterodyne receiver, now you're ready to actually test our AM superheterodyne receiver using this AM modulated CSV input. For each of the 8 local oscillator frequencies that you calculated in section 5.2.1 of the lab, enter that local oscillator frequency either by typing into the text box, for instance 500 kilohertz, or moving the slider, or dragging the knob here corresponding to different local oscillator frequencies. Once you have your local oscillator frequency selected, then head over to the controls panel and press start to actually stream this AM modulated CSV data to the 82 with multiplication by a local oscillator at the frequency that you specified. And if your AM superheterodyne receiver has been constructed correctly, then you should hear unmistakable sound waves emanating from the audio speaker for different carrier frequencies. Now note that even after you press start, you can continuously adjust the local oscillator frequency, for instance by turning this local oscillator knob, and you should hear the corresponding change reflected in the audio output. And this is exactly like a physical radio, where you can turn the knob on the side of the radio in order to listen to different broadcast stations. Record a video of your AM superheterodyne receiver playing each of the 4 audio signals at 2 different local oscillator frequencies, and you'll be submitting this video as part of your post-lab. Once you finish testing the output of the superheterodyne receiver, press stop to stop streaming the CSV data to the 82, and then press quit to close the EECS AM superheterodyne app. So this concludes the in-lab portion of Lab 4, and I hope you enjoyed this lab.